Jelly, are you excited for another video lesson? It's about exponential regression. So we're going to take a look at the exponential regression pages that we sent out to you. Notice this is the second page. We'll go back to the first page and run through that entire example in just a minute. But I want to take a look at the screen that you're going to see, which is that screen right there on your calculator, and figure out how do we actually write the equation for the data. So when you look at the equation on the screen, what it's saying is it's saying put that number in for A and that number in for B. So if we want to go ahead and type that out, we'd have y is equal to, now I'm going to round to the 1,000. That usually gives me enough information. Oh, I do not need parentheses to start this. I'm going to put parentheses around our base. And that's our equation. The coefficient of determination is r squared, and we want that to be close to 1. So in this case, r squared is 0.9992. We only use r if we're talking about a linear relationship. So our best way to judge how good a model this is based on the r squared. So now we're going to actually go through how do you make this model. And we're going to go back up to the first page to look at that data. And that data was about the year and I believe public transportation fare. I'd like you to go ahead and put this in on your calculator. I have already put it in on my calculator. So if you want to pause right now, that would be a good time, and restart the video when you have the information in on your calculator. So you can see I did stat, edit, and then entered the data. My first step is going to be to look at a scatter plot. So I went into the stat plot menu. I see I've got it set up for a scatter plot with L1 and L2, and that's where I input my data. And now I'm going to hit zoom 9. Now, one thing I noticed that this does, I mean, they're kind of on a line, but there really does seem to be a definite curve. But I'm going to go ahead and run the linear regression model. So to do that, we do stat, calc, linear regression. I've got L1 and L2 in, and I'm going to calculate. Now, the reason I ran the regression was because in order to get the residuals, to look at the residual plot, I need to have run the model. So now I'm going to go back to the stat plot and change my Y list to be the residuals. And remember, that was second list and then choice 7. And again, to set the window, I'm going to zoom 9. Now, clearly there's a pattern. With as few data values as we have in a lot of our examples, it can be hard to tell if there's a pattern or not. But here, there's definitely a pattern. We also thought that when we looked at the original graph, there seemed to be a curve. So we're going to say the linear model is not appropriate because there's a better model out there, and we're going to try to find it. Now, we're going to go right to the exponential model. So to calculate the exponential model, we go stat, calc, and now we're going to arrow down until we see the choice exponential regression. Our X list is L1, our Y list is L2, so we can calculate. So this is the model it's giving us. The first thing I noticed is the R squared 0.9985 is very close to 1. So that tells us it's a pretty good fit. And if we want to see if it's the best fit, we should look at the residual plot again. Now, I've already got it set up, and since I've run the model, the residual category has changed for this model. So zoom 9. To me, that looks like a random scattering of points. So I'm going to go ahead and say that the exponential model is a good fit. Oops, I lost my equation. We'll just run it again so I have it. Okay, so now let's go ahead and put that model in on our worksheet. That was on page 2. I also have it on my calculator. So y equals 0.002, open parentheses, 1.070, close parentheses, raised to the x. So it says, what should the fare have been in 1998, rounded to the nearest cent? So we're going to take our model, oops, I forgot to type this in correctly. That would be raised to the 98th. And $1.52 is what I calculate to the nearest cent. Now, I do recall that when I did this the last time or another time, I went ahead, well, I'll show you what I did. Because you do get kind of a different answer, and I would accept either answer as long as I understand where the numbers are coming from. So if we go back to our calculator, and in y equals, we put our regression equation. How we can get it is by hitting vars, statistics, and then arrowing to the right twice. Now, I should have checked to make sure there was nothing in there already, but I knew there wasn't. And then we want to make sure that the table set is on ask, which it is. And we can go into the table, which was second graph, type in our 98. And you can see that's kind of different. That's $1.94. So rounding does make a difference. I would accept either answer, but I wanted to show you both. The one nice thing about the one that I typed in the page is you can really see where it came from. The other one might actually be a little bit more accurate. Okay. For 2018, again, if we take our model and 2018 would be 118. We end up with $5.87. It's really hard to tell if that's reasonable or not. And the reason I say that is because 2018 is so far outside of where our data was. Our data stopped in 1995. So that's 23 years later. We don't know if it's going to continue to follow this pattern that far out. So I'm going to say it is unclear if this value is reasonable. 2018 is far after our observations. We do not know that the model will still be valid. Trying to make predictions that are so far away from the data values that you observed is a process called extrapolation. I'll say it again, extrapolation. And it's not a good idea to extrapolate to find the data values. The final question here asks us if we know if the exponential model is a good fit for the data. I'm going to base it on Okay, so first I'm going to say I think it's a good fit for the data. Now, part of the reason is the linear model was not an appropriate model, and the R squared, or the coefficient of determination, for the exponential model was close to 1. And again, I showed you that we can also do a residual plot. We're not going to ask you to go that far after the linear model. We're going to be all right with, well, does it seem like a good fit? Does it look like it's right? If we had tried the quadratic model or the quadratic regression, we would have found that the R squared was a little bit lower, and that would lead me to believe that the exponential is a better model. So you've got a couple pages of homework. Give those pages a try. And contact us if you have any questions. Have a good day.